Hey folks, thank you for joining. Yes, so today's topic is prototype to production. And before we start, I think you know I'm Anuj Jain and his Advay.
Advai.
We both work for Fabric Group, right? And I shout out to them because they are the ones who have kind of organized this and we are hosting this out, right? I'll just move forward. Uh, just before we start our set of ground rules, we want this session to be a bit of an active, engaging session, right? So let's engage. The second one is mostly for us. We need to be respectful of the time, but surely, like if you have answers, we'll try to time box things, right? And then we also have a networking time later on, so we can do it over there. And the third one is let's try to limit our distractions, right?
Okay.
Uh, about so let's get started with the about Fabric Group. So Fabric Group, we at Fabric Group are a full service technology consultancy company, and we have proven records of working with enterprise clients and delivering them digital assets and building custom solutions, right? We have 100 plus global consultants, majorly across the Asia Pacific region, and the next slide basically covers that. So our base is in Australia, and majority of our individuals and team members are based out of Australia. India being the biggest offshore team, and we have around 30 plus consultants within India, and we are looking at expanding across the APAC region, right? So that's about Fabric Group. I'll move up next. So yes, again, we are the hosts. Uh, Advay and myself have been working with Fabric Group, and you know we have been working and building these enterprise-grade solutions. And majorly, any solution that you build, right, needs to be scalable. It needs to be uh, reliable, and it should support a lot more. It should be kind of it should support a lot more durability and reliability. It should be a reliable product, right? And when it comes to that, you obviously in most of these things you need a process kind of a thing where you have a workflow kind of mechanism, and that is what we have been building. And with the AI agents coming in, again there's always a need of building these resilient products, and that is what we want to cover. How you can start from building a resilient product and take it from prototype to production, right? And that's what our talk is all going to be about.
Right. So,
Over to you, Advait.
yep. So, in past I have worked with a lot of startups and also enterprise grade applications. I've taken the small products like starting from no users, greenfield projects, up until to millions of users and transaction in production. So, with that, I think we have discovered few of some methods with few tools that we along the way, and we feel that these are generally good to have strategies when you are taking your products to production. So that's the today's talk is about. Yeah. And I'll quickly start with resilient agents. So when we are talking about AI, generally when we start talking about software, right? If we see, we are trying to automate the processes. Starting of software has been like complex computations to automating the processes. So far, what we have done is we have taken a quite an interesting approach in software development. If you see generally, we try to automate the processes, but in a way which are broken down into non-stateful functions, right? When we say I want an API call, I want to get a user, right? I build an API, go ahead that. But essentially, that is not what the process is. I probably want to buy something. I probably want to sell something, and that's when the whole workflow comes in, right? So we generally want to go with the workflows, but we never build it like that, right? With agents coming in, a lot of things are going into workflow because we have seen agents orchestrating a lot of things, right? We have we are seeing agents taking control of the processes, identifying okay what is the next task, and I need to do this, that, and all of that orchestration, right? And inherently that brings in the need for having resilience. So why resilience? Because now when we say we want to have like, we don't want our fragile agents, we don't want our systems to fail, right? And inherently what happens is bringing on LLMs, AIs, that adds on the cost factor obviously. So we want to limit that. We want to make sure that we are processing it in such a way that it is process effective, right? That it is cost effective, that it is time effective, a lot of these things. So these are some common factors that we see when we talk about lost progress. Like, we don't want to lose the progress, right? We want them to have, like, if my agent is orchestrating the data, we want to make sure that if something fails in between, I don't want to repeat the first few steps. Right? That's essentially what we always want. We don't want it to be difficult to debug. We want to have a visibility. We want to see what agents are doing behind the scene. We want to see how they are interacting with different kind of systems, and that inherently we see that a lot of things, when they are happening in Magic, they are obviously difficult to debug, right? We start from retries. So retries is a very interesting fact. In the industry, we have seen when the systems fail, we go back to using exponential retries, or maybe linear retries or something like that. But we never know when the system will come up. If we are interacting with some system and we want to do the retries, we never know when that will come up, right? So we want consistency in those retries. We want to make sure that our systems are interacting in such a way that retries do make sense, right? And what happens is, when we are not able to show and see what we are not able to showcase these products, it inherently becomes a poor user experience. If you are not able to tell user something went wrong, but what went wrong, what should you do next, if you can't tell the users, that's a really poor experience. So taking all these factors in, we have a term called resilience. And what would that typically mean? There are a few factors. First is reliability. We want full fault tolerance, right? We don't want systems to fail. We want auditability on the system. We want to see what is happening with the system. We want retriability, obviously, like we talked about. We want traceability, right? We want observation. We want to have monitoring on the systems. We want those things. And very much important from my perspective is idempotency, right? It's a very interesting term since computer science generally, right? So I hope all of us understand what idempotency is. May I get a show of hands how many of we don't or have? You don't know? Fair, fair. So let's talk about it. Idempotency is exactly one's safety. Or if I ask you a question, what is 2 plus 2? What is 2 plus 2? What is 2 plus 2? That's idempotency. If I'm giving same set of inputs, I should always get the same set of outputs, right? If I create a user from my email, right? Now the system has said, okay, I was able to create a user. But next time, if I try that and my user is unique in the database, will I be able to get that? No, it will give me an error. So that is not an idempotent scenario, right? So whenever agents are coming in, we have different scenarios, right? We have different set of inputs happening, and inherently with LLMs, different set of tokens are taking place. All of that in place, we want to make sure that we reduce the work of agents, right? And we want to have them idempotent in nature. So this all put together, we want a system called as durable systems, right? So durable systems are inherently taking the state of the actual system, right, and coupling it with the execution history. Like we have, I hope folks have heard about something called as event sourcing, right? Probably have. So event sourcing is like ledgering systems. We record all the events and we always keep track of states in that. So that gives us a whole term called as durable systems. So there are a lot of platforms these days. With this coming in, we have workflow management platforms. N8N is very common these days, right? So few of the platforms that provide durable execution particularly, I personally got introduced with it with durable functions from Azure. That was one of the first in the industry, in my opinion, obviously. Then there was Temporal, right? There is Orcus that came out as a project in Netflix Conductor, which was later open source, and then there is a managed solution called Orcus from it. Restate is something that we'll talk about today, right? It's an open source project with a managed platforms solution that will dig deep into. And there are different platforms like AWS Step Function, Convex, and Littlehouse, which if you are interested, you can obviously take a look into. I hope we are making sense up until now. So let's jump into what I'm talking about, resilience agent, right? I'll quickly go on and show you what we are trying to say. So when we say, you know, what we'll be doing today is try to recreate a scenario for credit card recommendation system. So when I talk about credit card recommendation, it inherently is a very complex domain in terms of banking, because there's a lot of factors coming in. First is your spend analysis, how the user spends his money, what's the income, what's the experience, credit scores, right? And what's the KYC status, all of that. There's a lot of factors. So if I go in a typical banking system and try to see it, there's thousands of different fields which we are trying to have computations on, right? And with AI, this is a really good use case for banking sectors, I feel, right? So we'll have a web app, basic React app working on. We'll have a backend with Node.js. I hope folks here are comfortable with Node.js today. Yeah. We'll have Restate. Restate, again, as I said, is a open source platform. So I'll be running that on Docker containers on my local. When we were talking about, we always work with microsystems, right? So we want third-party services to provide us, let's say, user information, experience data, credit history, and all of that. And finally, we are using OpenAI as connectors for our LLMs, right? I'll just quickly jump in to the code. I hope the screen is visible. Yeah, sure, I'll go to. Before that, I'll quickly go into the system. Okay, so let's say I'm a user logging into the system. We have a pretty good UI. I click on get recommendation. So you can see I have some more like credit score, utilization of credit, annual income, if there are any existing loans, all of that. Based on this, my AI agents are now going to execute. So there are probably 4 agents coming into picture, starting with first one here. I'll quickly go to the code and talk about here. So we have different agents. So we have category spend analysis, right? We have financial trends, right? We have recommendations based on the data, and we have risk profile analysis. So these are 4 agents that I'm running behind the scene to get the recommendation for credit card. So essentially, when we saw that there was a bronze market and gold mirage matching for the credit cards, that's essentially 4 of the agents coming into picture altogether. Now, how do we do it? We use Restate, like I said, Restate, right? So Restate is a platform that provides us 3 different kind of virtual services. Right? So first, starting with resilience, I have something called as virtual service. When I say virtual service, it's as good as a function, right? And yeah, I'll quickly go in and I'll say that, okay, this is as good as a function, I'm getting transactions, but this executes in all the promises that reliability is providing. Yeah, this is tracked into an idempotency key. We have, if the system goes down, Restate will make sure that it is getting retried, right?
So it is having some memory persistence.
Yes. So to help you out with the platform of Restate, we have Restate working with something called as RocksDB. RocksDB. It's based out of Rust system ecosystem. To go into the networking details, it is using Bifrost protocol to have communications between the nodes, and it is kind of a cluster itself. So when Restate comes up, when you will run it in production, let's say, it will have a cluster of Restate pods coming up. It is a sit-in between agent, right? So you will have systems, your client communicating to Restate, and Restate will then further transfer the communication to different kind of systems downstream, right? So best thing about Restate is we are just defining things in Restate. We don't do more than that. So like I said,
So it's if I understand, it's a event source kind of database, right? It's publishing
RocksDB?
I mean, yes.
Yeah, so what happens is we have different, it kind of balances between the different kind of communications. One is it takes your client's request. It will have request response synchronous communication with the downstream virtual services, as we call it. So for example, if I'm running something in ctx.run, if you see here, I'm doing this line, ctx.run await transaction. This particularly is a line of code which we will say is a virtual service. Right, so I've just defined that, okay, I want a virtual service to be executed. I want to run something, and underneath you are supposed to go and get some data for me.
Basically, it's a business function, right? Virtual
Yes, yes, it's a business function, but I don't need to add in anything like retriability. I don't need to particularly add in any kind of exponential backoff or anything like that. I don't need to manage that. Restate will take care of that for me. Does that make sense?
Are these features that you mentioned, are they there in LangChain or any other orchestrators?
No, you'll have to build it on your own. So that's the best thing with Reset. So it's kind of a system that takes care of all of these things for you.
So what I understand, this is basically you can say a service layer, then you have an
Yes, yes.
agent layer, right? So it is communicating to the agent, but you are not directly invoking the agent. You have the Restate in between.
Yes, yes, yes,
managing,
yes.
your workflows, right?
Yes, yes. Sit in between platform that kind of takes care of my workflow management all. And with that too, with a lot less configuration. So more or less, if you can see, I'm just telling Restate, okay, you are supposed to get the data. I don't tell it anything apart from that. There is no configuration related to it.
And behind the scene, these when I say get transactions, right? They have their business function. They go and
So there's a combination. So if you see here, get transactions particularly is a business function, right? When we go down, we are identifying category spend, we are identifying financial trends. So these are different kind of agents coming in hooked, right? So you can do whatever you want to do. It's basically code, right? I want to call something, but I don't want to have like try catch block. When my catch fails, okay, I want to probably lock something out, do something. There is nothing like that. Just to demo that out, we'll go to Restate UI to make sense out of it. Before that, I'll just quickly go through what we are doing. With this, we have a Restate workflow, right? So if you can read it, we will start from fetching the user data. We will get some user data, right? Then we'll have computing the profile, where Restate does like identify category spend, financial trends. We are computing risk profiles, and finally we get the card recommendations. That's the whole workflow that I have told Restate to, nothing else. Yeah, you can go anywhere else in the project, and there is nothing related to particularly Restate there. It's all other parts of code, like maybe OpenAI connectors, maybe some downstream API calls or access or something, but nothing else. Okay, so when I go back into let's say my invocation, so this is called as invocation in Restate. One particular call to the service to a workflow is called as an invocation, right? So all these things that we just saw, right, we are starting here. So it shows that we started running it. We are taking all the user data, user income, user experience, all of these things, and then it shows that okay, now when did it got complete, right? So everything here is taking some arbitrary amount of time. So we can see how the systems are experiencing, what are the return values. Even if I go to let's say experience, it can show me the value of what was the response.
Yeah. And in my opinion, I think this is one of the most important USPs of using these platforms, right? Again, coming back to your question, Shreyas, when you talk about LangChain and other things, the agents that we are calling over there, right? That is where LangChain agents and whatever chaining you are doing with LLMs comes into picture. But when you need a bit more kind of observability on what is happening behind the scenes, this gives you a much more cleaner view into understanding what is actually going on over here, right? It helps you pinpoint the problems within your AI agentic flows as well, and it gives you a visibility in terms of how much time everything is taking uh, while maintaining the state of it, right? So that is where I think Restate and other platforms like Durable Function Science.
Right, so
Right.
all the purpose of these platforms is to provide that in between visibility that we need without taking care of all of that. So if we say, right, we are building some kind of a workflow where I have to typically go and call 4 different services just to get one call, like we did here, right? To get the recommendations, I had to run 4 agents, then some API calls in between. what we would typically think in architectural terms is something like an orchestrator, right? We will have something like probably, if it is a single, we will have choreography or sagas or whatever it is, right? But this is a platform where you don't need to build that orchestrator. This is the orchestrator for you, if it makes sense. Yeah. With all of that, I'll quickly show you an example of how Restate handles errors. So let me go to the service and probably, let's say, recommendations, and I just say that we are going to throw the error, right? Oops. Okay. So going back. I'll go back to the invocations, and here you can see I just threw an error, and now you can see Restate trying to make those retries. Again, something that I have not taken care of, but it comes out of the box with Restate, right? I go back, I'll just change the code to fix it. Okay, my service is back again. Now probably, okay. Yeah, and we saw that, you know, my last step was failing. It suddenly got back on track after 35 seconds, and my workflow is done. Now, effectively, none of the steps above were computed again. That's idempotency, yeah, out of the box. No, since there are 3 agents, my LLM and API calls are reduced here. We are making not invoking them again and again and again. Once we have a set of data, it's there.
And just to add over there, right, why this becomes very important with AI agents is because you don't know how much time your AI agent is going to take to respond. Sometimes your agentic workflows can take a lot of time, sometimes they are quicker, right? And what is the lost progress behind the scenes on your servers, you need to know that somehow, right? And that is where these things come handy, so that you don't have to do, you can think of it, right? You setting up these retry mechanisms, idempotency, taking care of all those things takes a lot of toll, and a lot of effort goes into kind of creating these systems, and these platforms kind of provide you with that.
One thing I'm not able to like understand is,
Mm-hmm.
let's say your system is transaction, right? Like
Mm-hmm.
the like you say your e-commerce transaction.
Mm-hmm.
So user has journey of checking out the item, adding to the cart, right? Ordering and payment. Let's say now your last step failed, right? Ideally, I mean, like let's say if not e-commerce but in the banking transaction, other steps should be rolled back, right?
Should be
Rolled back.
rolled back.
Right?
Yes.
Your transactions failed, right?
Mm-hmm. Mm-hmm.
So other things we rolled back, right? But this is, I think, is not probably the case which fit into that.
Well, we can discuss on that. One is it can provide you a rollback, because this workflow I haven't configured it to be rollback. It's but effectively it's just a line of code where it's I can say that if trackers goes wrong, if I don't have something, I can roll it back. Now, to answer your question in some different business aspect, if we are talking about user card, there can be business case where we don't need to clear the card, but we need to unlock the inventory. So that's a selective rollback. Yeah, even that is applicable here. So it depends on how we define the business. All you have to do in the Restate is define the business whatever you need. There is no need for handling it manually. I hope that answers your question, right?
It depends on the like.
It depends on how you define the
Of
workflow.
journey is like.
Absolutely, absolutely. So I haven't added it, but you can as simple as catch the error if there is any, and if you tell Restate, okay, if this is an error, I want to unlock, let's say, my inventory, but I don't want to clear the cart, right? That is selectively applicable.
Also, Advai, I think Restate also supports different kinds of services. Like one is virtual service, one is workflows, and things like that, right?
Yes.
So via that also you would be able to kind of play around with these functionalities like rollback and other things.
Right. So if you just want to do durable execution, all these retry, idempotency and this thing, Restate provides the first layer, which is called as virtual services. Right. There is second layer added to it, which is called as virtual objects. Now here you take the virtual service and couple it with the state, right? So you store some data with that. Now because this is kind of a workflow, uh, you can see all the state is being maintained here. Everything that I am interacting, whether that be with LLM, whether that be with my external APIs, all of that is recorded here as state, right? And finally, Restate provides something like a workflow which is effectively human in place, right? Because all of workflows, most of your workflows would be human actions in place, right? Approvals or
When you say output, right? So sorry, state, right? So let's say my LLM agent one, right, returns something, right? That will be maintained by Restate, right?
yes.
Pass on to the other agent, right?
Absolutely. So just to make things clear, I have my agents returning me data in JSON schemas. So I am not taking in the raw text output, I am taking in the JSON output. Hence, my agents, when they respond, I am getting, so if you have used something like AI SDK, we are returning the objects here. Yeah, we are returning essentially the objects from AI agents. Hence, in the state, you see these as JSON objects. If it would be text, that will also be retained. It doesn't matter what you keep in the state. Yeah, and how to set the state? It's effectively this. So I am essentially setting the state effect here, right? So it can be anything. Restate as it's a it's not relational or anything. You can define your own state. It's a key value store essentially. Yeah? I hope that makes sense. Cool. Yeah, so also with Restate you can, as I showed you, there are different sorts of state related to it. Your workflow can have state and your virtual objects can have state. Only difference between two is workflows can halt in between when there is a human step needed. So if your workflow has like a human action required, it will get paused, it will wait for that human action to be complete. Asynchronously, you can hit it and tell that human action is complete with whatever input you have, and it will start continuing with that. Right? Okay. I'll quickly go back. Here's what we are doing. Just to set in the context, we saw that external services like user were running on port 4000 on my local. OpenAI for connectors, backend was running 3000. Web app again 517. It's a weak default, and Restate was running on 9070. Yeah. Any questions so far?
Does this scale horizontally Restate server?
Yes, that's the main essential. To get a bit deeper into it, your Restate will have, obviously, if you are deploying it in Kubernetes, it has native Kubernetes support, so it will have different pods. You can scale that horizontally as well as vertically. The nuance to it is your pods should be able to communicate with each other, so you have to publish the address. You have to broadcast the address, and that's something native to Kubernetes, right? We do it obviously. So if you are, they are able to connect with each other, and it requires EFS, file system underneath, for RocksDB, persistent layer. That's about it. So it will make sure that your executions are not scaled to only one pod. You don't need to take care of that. You just scale it horizontally, and it will start responding to your needs. By the way, all the request response in Restate are queued internally, so there is no conflict of data overwriting also. Okay, I think I have covered enough on what Restate and my resilient agents look like. So if there are any questions, throw it at me, anything.
So have you tested it in the production?
Yes. Yeah.
And what's the scale? And like I'm just doubtful, like you said, it works with the EFS, right? So EFS is not very scalable when it comes to.
So there are two layers to it. built on top. So when we are, it essentially write log file and then it asynchronously syncs it to EFS. So when we talk about latency, if I show you the latencies in the system right now, it's more or less my intentional efforts that I have added like 1 minute of it. But if you see that running starts and all of these are like in milliseconds, no, not even in milliseconds. It is compounded on top of protobuf. Like I said, it uses Bifrost protocol, so it's really fast on networking side. It is because it is an asynchronous write to EFS. It is not heavy on the persistent layer also. So your streams and logs are flowing effectively, like there is nothing in between. Obviously, few milliseconds in production, but not that much an effect.
This probably has replicas behind it. If it is great, right?
Yeah. Uh, giving you an idea, in around scale of 50 million users, the latencies are probably around 30 milliseconds for restate. Then there's a now the performance again depends on how we are writing the code, obviously, but
So your use case was mostly around using Restate for the agents, or
so
any
agents,
other
no, we came across for Restate for very much of a human in process workflows, workflow automations, but this works really well with agents as well. So that's the conversation I wanted to have.
Yeah, and one thing to add over there, right? If I want to kind of build a web app which is calling an agent at the backend, it is quite useful for me because I just need to create a virtual service, and it takes care of retrying my workflows, checking the state again and again. I don't have to kind of worry about the peripherals of building that system up, right? So that is where
there
it
is a lot of
reduces.
clutter when you orchestrate stuff.
Exactly.
Absolutely.
Saga for your
Yeah.
Absolutely. So you have to have messaging brokers in between. You have to, and typically we would go with Kafka. So there's you have to have partitions. You have to have consumers aligned to it. So all of that complexities are behind. This eliminates that instantly. And with agents, it kind of works well given that it is very idempotent in nature, right?
So it also, acts as a alternative to MQ9 and also the other services, right?
Absolutely. I mean, as good as you use it, it's basically
So we can have the ability to.
yes. Any you just need to understand the business, I guess. Apart from that, infra is taken care of. I guess that is all about it. So typically, when we take these system, we build a system. Next thing is before going into production, we'll have testing. We'll have a lot of these things, right? So that's when the next session of the talk. I'll hand it over to Anuj for that.
Yeah. Thanks. Cool. So whenever you're building these, complex systems, testing is one of the aspects which is always left behind, right? Right from developers not writing the unit tests, and probably now because of TDD and PDD kind of things, people have started using and writing tests and taking tests seriously. But again, when it comes to testing the end-to-end flows, it is still a thing which is not you know done properly, or causes a lot of problem when it comes to testing end-to-end cases. And that is why we came up with this framework of identifying how we can supercharge these mocking scenarios, right? So we have come up with a framework which helps us do this, supercharge our mocks, and test out multiple end-to-end scenarios quite easily. Uh, Before I jump to the actual framework, I would like to set some context around so that everyone is on the same page that what are mocks. Mocks are just controlled fake version of real dependencies. They replace the real systems. They have predictable outcomes or responses. Basically, if you give me X, it's Y response, right? They help me isolate the code. They help me isolate test out a very specific section of code, and they also help me verify interactions. Uh, Say I'm connected to service B, calling an external service, say KYC, and I'm a lot of times depending on that service to be available, right? if these services are not available, what do I do? And if I have the contract ready, I would be able to just verify my mocks with the help of verify my contracts with the help of mocks and go ahead from there. Uh, there are different kind of mocks available as well. Like again, we have tried to draw a parallel with the test pyramid, right? You have the unit level mocks at the bottom of it, where we are mocking the normal classes and things like that. And again, on the right hand side, you see the tools that help us achieve that. Then comes the service level mocks. When dealing with microservices, you're mocking the external microservices, and majorly these mocks work with API virtualization, which we'll get into a bit in detail. And then you have system level mocks, which is again a bit higher on the test pyramid, where you're mocking a lot more complex flows, right? You're dealing with complex flows. You're dealing with third party partner ecosystems, say partner gateways or things like that, right? What we want to focus on today is this rectangular box that we see, which we want to kind of talk about API virtualization. And building any application today, you are calling APIs and a lot of APIs, right? And API virtualization really helps you test out or mock some of your external dependencies and test out a lot more scenarios earlier on in your life cycle, development life cycle. Just a refresher on what API virtualization looks like, right? You have service A that you are building, say the service that Advait just showcased, right? That's our service under test. You're calling some external service, which is service B. And in a general setting, what happens if I'm not mocking that? I am a lot of time dependent on whether that service is available or not, up and running or not. If there are bugs, any bugs available on that or not, right? And that slows down my testing effort, that slows down my development effort, right? And in order to kind of work around that, what we end up doing is we create a mock server, which is kind of just mocking or acts as an imposter to my service B, right? And that example that you see over there is an example taken from a Spring Boot configuration file, where you just need to change the base URL to point it to the mock server, and your application starts working. It's as simple as just replacing the base URL from where you're pointing. And traditionally, these mock servers, any mock server that you pick up, Mockun or Mockun, Mountbank is one of them. Mock web server is also one of them, I think. Yeah, Viamock is one of them. Thank you. Viamock is one of them. So anything that you pick up, these work on predicate matching, right? Where you try to identify what is the predicate, say whether it is your endpoint, whether it's headers or something like that, and they help you return back the static responses or the dynamic responses. Any questions so far? Cool.
I think one point to notice here is that whenever we are going to mock server, we don't change the path. They effectively, your configuration and everything
Yeah.
remains the same, right?
Exactly. And that is what gives you the benefit of kind of just replacing your external dependencies on the fly. Yeah. So traditionally, this is how any mock server would work like, be it Mockun or Mountbank or Viamock. You are calling an API, say get API user for user 123, and once you hit the mock server, it tries to do the predicate search and predicates in a very simple language. It's not always like this, depends on the kind of mocking framework that we are using, but generally what it is, a pseudocode for that would be, if endpoint is this, then I want to return a success response. If my endpoint is 234, I want to return a no user found response, right? Now, what happens with this is, suppose for user 234, I want to test out a success scenario. I'm blocked, right? Anyone of you who has used Mockun or any of these mock servers before, right? Yeah. So how would you generally would go ahead and change these mocks?
So we would have a config. So normally, like the way I use it is config driven.
Yeah.
So we just define that for this particular path or this username, for instance, this is what I return. And then the server, the mock
Yeah.
server would then take it from this configuration and return appropriate responses
Yeah.
upon request.
Exactly. So at some point of time, you are changing some static files that you have, and you are again redeploying your mock server, right? those are kind of the challenges that we wanted to kind of resolve with the mocking framework that we are looking at. Uh, so let's talk about the challenges a bit. One is, again, these challenges are, let's say you're building an application, it goes to your dev environment, then staging environment, then UAT, pre-prod, prod, or something like that. Usually in dev environment, what we like to do is test out a lot more scenarios. Uh, and most of the times these dev environments or QA environments are mocked. I don't want to kind of hit my real systems, external systems, because say I'm working with for banking application, I'm hitting KYC. I'm dependent on KYC details. I'm hitting a PAN details API. I'm dependent on NSDL, whether they have a proper running working API available or not, right? So that brings up the challenge of creating these test data across multiple different services, and a lot of coordination is required. So that is one of the biggest challenge. Second is, as Simra was mentioning, you have to kind of create or update the static files and redeploy it. So there's an overhead of redeploying these agents, these mock servers again and again. So, and someone would have to kind of go and keep on updating and maintaining these things. In a system which is large enough, it becomes a mess to kind of even understand which is the user, what kind of response is returned for which kind of user, right? And again, when you want to automate these things, it becomes a totally different mess out of it.
We'll probably end up using something like Google Sheets to maintain this data.
Yeah, true. Uh, and that brings us to a chaos of test data, right? Uh, Teams would have usually shared test data, and again, when you look at it from a UAT point of view, right? There would be teams who would be dealing with just 5 to 10 different sets of test data, but the number of end-to-end scenarios that you might want to test would be 20, 30, or many more, right? uh, Working with this kind of test data is quite difficult, and again, test data is can be stateful as well. Say if I'm doing a pan and I'm matching it with linking it with my Aadhaar in one of the systems, right? That is a state change for me. Now this pan I cannot reuse to test out the same scenario again, right? So that kind of creates a problem, and then I would have to reach out to my external dependencies and ask them to give me or provide me with an APIs or ways to reset this test data back, and that creates a problem, right? And the biggest problem is API chaining. Obviously, when we build these workflow systems, your output of one API becomes the input of the other one, right? Uh, I think a good example is again something on the similar note, or maybe taking an example from the resilient bank that we just showcased, right? You have credit score, and that input is going in as part of your agent input, right? And these things kind of become a problem because then I need a mock server which is able to accept these changes and create me mocks which are a permutation and combination of these things, right? Now, this is a very interesting problem that we have tried to showcase over here, and this would basically help you understand the problem a bit more. I'm just setting the context here right now because it is not an easy problem to solve and understand. So, let's say we have a workflow system or application which works with 4 different APIs: the income details one, the Experian, which is for credit score, right? The third one is fetching the bank details, and the fourth one is KYC, right? And the down below that you see are the number of unique responses that I can expect from these systems, right? 2, 3, 3, 4. If I assume that all the permutation and combinations are possible, that gives me with 72 possible scenarios
Your
that I would
QA will definitely get into this.
yeah. And many a times, most of the times, a QA would identify that scenario for which you don't have the test data to, right? And that is one of the major problems that generally we deal with. And down below, what we see is, let's assume you have this test data available for 001L PAN card user. Income details gives you success, Experian gives you not found, current account for bank details, and name mismatch for KYC, right? And so on and so forth. Now, if I want to kind of test out a scenario where I have a success credit score of 800, success for bank's details, and say success for KYC, it's a whole lot of trouble for me to kind of create this system, whether I'm using a mock server or whether I'm not using anything. I'm actually connected to external services, right? As you were mentioning again, if I'm creating a mock server, I would have to go to that mock server, create these users, and do it. With the framework that we have built, it is as simple as a simple click, right? You click once, which is kind of creating this test data for you, and you have that test data in hand with you, right? So we'll quickly get to the demo of it so that it gives you a much more understanding. Modulus is what we are calling it right now. I'll quickly showcase you how it looks so that you get the feel of it. And then we'll try to go into the details of, what are the core concepts of it so that it's better for you to understand. Cool. So what we've done is with the mock server, we come up with a web tool as well, which is kind of a UI which allows your QEs or quality engineers to pick and choose the combinations that they want to test out, right? And so this is what it looks like. For now, I have three APIs: Experian, income details, and transaction details. If I expand on it, I get these many different kinds of responses within it, right? Success with 760 score, success with 600 score, and 800 score. Let's say I want to test out a scenario with 600 score, and then I have income details over here. Say I want to select 15 lakh, right? Uh, Transaction details I don't have much, but let's try to generate this data. What it ends up giving me are some set of unique values which I can use, which become my test data basically. And these values I can use as part of my testing to fetch the responses that I have mentioned over here. So let's take this one, this as an example. I go back to my server, right? I give this, right? So just before I click next, just cross check. What I'm saying is I'm looking at 600 score of credit score, 15 lakh as the income, uh, as part of income details. Now when I click next, you can see I get 600 access score and 15 lakhs as this thing, right? And the same user or the PAN card over here that we are considering is taken ahead, and we are proceeding the workflow with it. I can get the recommendations with this as well, and my restate would actually start working. And over here again, the idempotencies key, or the key that is defining my workflow, becomes that PAN number or the user that got created. So this helps me solve this issue where I don't need to kind of create and keep a lot of different kind of test data, right? And here it is, right? It has succeeded, and I have the bronze market and the bronze journey available. Yeah.
So this one seems like a manual copy paste, right? Where you're trying to test out your system manually. But if you have to automate using these mock responses for various scenarios, say the 72 scenarios you mentioned, is that also possible to automate that?
Yeah. So essentially, as you can see, this is a manual UI thing for the QE quality engineers kind of test. We also have an API. So this particular API can be used as part of your automation suite to help you automate all those different kind of scenarios. So uh, and
Put the criteria that you want to generate data for, right? And
exactly,
then spit out the number of
exactly.
testers. Okay.
And that we'll have a look at it as well, of how easy it is to kind of create a create data via the APIs, and also how is it easy it is to kind of create these responses within my mock server. If I want to kind of spin up a new service or add a new service to this mock server, how easy it is, right? uh, any questions?
So, QA, there could be different QA scenarios, right? This is just a business side, right? There could be an API testing as well, right? your status code 404, like
Yeah.
500, right? How we will extend this?
Yeah, so basically this, as of now, what protocol we are serving out of it is the HTTP protocol. So you would be able to change your headers, you would be able to define your status codes, you would be able to define your body and all those things, right? We have also tweaked it to kind of return a PDF file from, rather than going to S3, I wanted to kind of get it from my mock server, right? So these are the things that are possible to do as of today.
You have this admin UI to feed these, like what kind of test server I want to spin up mock server?
Okay, so we can go into the
Yeah.
presentation and we'll revisit back
Yeah.
on this where we don't have an admin UI per se, but we have configuration file for that. So,
Yeah.
and just also one on top, the errors that you see here are effectively going to result in 400 or something like that.
Yeah. So maybe you can pick up one of the combinations that you want to kind of see working, and we can just have a look at it how easy it is, right?
Yeah, one,
So maybe for the Experian API, which one should I use?
and then you do error, one and then error, incompletion.
Yeah, and I generate the mock, right? So over here, I get 001Z as my PAN card. I go over here, I log out from here, right? I use that particular user, and when I log into test case, it says your income data is not filled, but the credit score was successful and it gave me 760, right? So again, it is not something. It is something like whenever anyone comes up to you, even the product managers or product owners, and say, "Have you tested this scenario?" You don't have to worry about kind of going ahead and deploying your mocks again and again. It is as simple as just picking up the combination and creating a user and testing it out.
So you deploy this mock as a service in
Yeah.
your clusters, right?
Yeah.
Yeah. Let's revisit and
It's something like a stub kind of thing, right?
Yeah.
In QA we have, like
So-
many companies
so-
create stubs, right? Stub server with some test data.
So ideally, what we call it is our test doubles or over the wire mocks.
over the
But wire mocks are those are local to developer machines, right?
local to no.
So these are over the wire top mocks where you are calling it via the HTTP requests and things like that. Wire mock is one of the frameworks which helps you support and create these mocks.
That's what I'm saying, but those are usually those are part of your integration test, right? Where user test various service, right? This, what I'm understanding is this is more about the developer, this is QA level, right? So if you
Yeah.
deploy your service in the,
So-
let's say dev environment, right? And you mock these against the various
Correct. So
combinations.
you want to take that?
effectively, the concept in play here is API virtual service or
Virtualization.
service virtualization. Sorry, which you say that when we are talking about 10 different downstreams, we don't want like them to have, but we want the network latencies to come in between. We want that effectiveness. And if I go back into the pyramid that Anuj had showcased. If we see that, so there are different layers of mocking service, right? We can start from unit mocks, right? We have integration mocks that will play in, but when you go to the end-to-end scenarios and you want to visualize the journeys into that, we will have these virtual services deployed. So Mockun is a very good example of that you deploy as a container in your cluster, and it will start giving you the responses.
So that's what I'm asking. It's outside the developer's machine, right?
It is outside. It is
Yeah.
on the cluster. Yeah, it is
So
it
again-
is on the cluster.
It could be local as.
Yeah, effectively.
So I'll just try to explain it with an example, right? Generally, at integration level is what you are talking about, right? You have the unit tests, and then you have the integration tests where you're testing the integrations with external systems, databases, Kafkas, and all those things. Ideally, the latest thing over there is test containers. Is that what you use? Test containers also again create your Docker images and spin up the Docker containers. This can be thought of as the same thing, right? If you want to use it at the developer level as part of your integration test, you are very well, good to kind of spin that up at that level as part of your CI and run your tests against it. Also, what we also want to say is you can also use it, and we have found it very beneficial to be used in dev environments where I want to run my smoke tests, right, and validate all the things are working properly, right. It gives me also the power of testing a lot more end-to-end scenarios Whereas if I'm doing it as part of integration, I'm doing it for one service, right? It is not for my entire system, and my entire system can be built up of multiple microservices. So ideally, what we are saying is use it wherever you want. If you want to use it as part of an integration test for just one service, you can do that. But there are possibilities of kind of creating test containers and other via mock or something like that tools available to do that. The best fit over here would be a dev environment where you want to test out your end-to-end scenarios at a much more larger scale. Cool. So let's look at how this entire thing came up together and how we were able to kind of achieve that. Uh, so let me introduce some of the core concepts that we realized were really important to kind of build this framework up. One was the unique keys. Obviously, we wanted a unique way of identifying what kind of response I need to return, right? So basically, you can think of it as every API of yours would have some sort of uniqueness assigned to it or unique key assigned to it, right? That is what we define as unique keys. Uh, like in case of PAN or KYC, PAN card becomes your unique key, right? Uh, Second comes the response mapping. Now, this is a very interesting piece, and this is where, again, Simran, one of your questions ties back to is how do you define for what kind of unique user you want which kind of response, right? So this is basically your API plus unique keys help you specify a very specific mock response, and this is what gets generated on the fly as well, right? So this kind of response mapping is something that we store and we persist it, and that we'll have a look at it when we dig deeper into the framework. And the third one is obviously dynamic responses. We have to deal with dynamism when you are working with enterprise applications. You're calling, say, I'm giving a PAN to some service, and that service also returns my PAN back. So my mock should not be like it should be returning me some random PAN number. It should be my PAN number. So that is where I bring in the dynamic responses. This is just a very simple example, but you can do a lot more templating, and dynamic responses is achievable with the framework. Cool. Let's look at the Modulus way of mocking, right? What we've seen earlier compared to this, there's two very striking changes that you would see. First is the post call for mock user, and this is what we'll use as part of our automation as well, right? So what I'm saying over there is in the call one, I'm saying that create me a new user, and it creates me one user 123 with for which API 1 would give me a success response. And that is the kind of response mapping that I want to store and keep. And we persist this thing in a persistent storage. And this storage can be anything. Currently in the demo that we'll see would be in memory, but you can add a Postgres or MongoDB over there to solve your purposes. And there's one set of infra that is required to kind of support this dynamic responses, right? And rest of the things remain same, where you do a predicate search to identify what is the API that you want to call, and then you fetch out the response mapping for it and identify what kind of response I want to return back, right? And that is how we are able to achieve permutations and combinations of multiple mocking scenarios. Yep. So this is what we have here. What I'll try to do is, now what we maintain, these are majorly based on configurations. Is it visible? No. One second. But do I get that? Yeah, perfect. Cool. Now over here, what we see over here is we have a client and a server, but ideally what we are much more interested in the configuration files is the mocks, right? Right over here, this is how we usually maintain these configurations, where you have one folder defining the responses for one of your APIs, say Experian, and the other one. And you just maintain a index JSON which talks about what is the name of the API, how do you want to kind of show it on that UI, what kind of method it supports, whether it is get or post, right? What is the path of it, right? And what are the unique keys? Now, this unique key is a very important concept that we discussed earlier. I need to define within my API call, where will I find the unique key? What I'm saying over here is I'll find it in params, right? So this is from where I'll fetch this unique key, right? Modifier is nothing but the value or the selector name. So if it is body, you can also give a JSON dot notation to specify from where within your JSON you need to specify or pick up the value of the unique key, which will be checked against the storage. And the type is the type of unique key that you want to generate, right? What we also do is we maintain this list of unique keys, right? And these are configs again, which help you create new unique keys on the fly. So what we are saying over here, let's say, take an account number for example. It is an incrementing type, and this is the base number for me. And whenever I keep on creating generate mock, it would just keep on incrementing this number again and again. So before creating a new one, I always check what was my latest mock and just append based on the configuration that I have provided over here. Right?
Also, just few things to notice. If you see the mobile number section here, we have like regex helpers to generate us the data and all of that also. Yeah, and we'll have a few more things which Anuj will showcase.
Yeah.
So okay, so Experian essentially is a what do you say, a body, a credit score body in India. It's an org that provides the credit score, maintains that for it. So it's typically for an LIS for credit score in India. So in banking, Experian means credit score.
Right. So if we had to, I mean, obviously it could provide multiple APIs, right? So
Yeah.
it could potentially be a get, post, put. So if we had to define multiple kinds of API responses for those different configurations, how could we do this using this? Because what I see is, I think I saw a get there, and that was a string, not an object or even an array, right? So if I had to define for multiple kinds of methods that it supports, is that possible using the same configuration?
Yep. So ideally, what we one of the things that we are enforcing as part of this is one API would have one folder structure, right? So if it is a get API, say for getting something from Experian external system, you have one folder for that. Then if you want to kind of support post API, again it may be functionally doing something else, say creating or updating the credit score or something like that. You create another folder structure similar to that, right? And that is one thing which we have done now. Say income details was missing as part of this. I have just brought in income details back, and just to add those multiple different kind of mocks, these were the things that were required by me to do. One was just creating this JSON file, right? Which just says what is the name, what is the path, and defining my unique key. Then I define my error responses, and this is where Anuj, for your question, right? You can define the status codes over here. You can define or play with the headers, and you define whatever body you want to respond it back as, right? And this is again very simple. This also aligns with a bit of how Mokun does it. And Mokun also you kind of define these things like status code, headers, and then body. And generally all the mocking frameworks that you would be using, they kind of support the same notation of defining status code, headers, and this thing, right? One more interesting thing that you will see over here, we have templatized some of these things where you can use some functions like faker libraries or again, one more example that we'll see, you also have the request object altogether. So if you want to kind of pick up some of the inputs from the body, request body that is coming in, you would be able to do that and play around with it, right? And this is one example of that. This is for user 1234. If I don't want to hardcode my user 1234, what I can just simply do is do over here params and user ID, right? So this would pick it up from the params. If I want it from body, I can very simply change it to body, and again,
Whatever the location.
whatever location I want it to be at, right? So it's as simple as
These are the sample JSON or the actual JSON which mock server will return?
these are the
So effectively, index file defines your API, right? All the other files are expected to be the responses, different kind of responses. So when you go back to UI, let's say all these are the options that you get in the chip group, right? So if you add one more file, you will see one more option to be select in the UI, right? So if you want something like, okay, I don't have 502 right in this setup, but I want my QA comes to me, okay, I need 502. I can just add one more JSON file and that's it.
yeah. So I'll give an example of that as well, right? Let's just check how it looks right now, right? I come over here. For my income details, I get 4 options currently, right? Let's go and add one more, say 500 score, right? I added this. Um, let's keep the status code as that.
Can you also change the name, Anuj?
Okay, the name is wrong, my bad. Uh, let's change it to, sorry, this one. Yeah. This is, say, 5 lakhs income, right? 5 lakh income. This is an income detail one. Let's change it to 5 lakh, right? And change this to 5 lakhs. Cool. Now, once I refresh my server, I also start seeing that additional response over here. I get 5 options, and then I have 5 lakh coming up over here. Right? Now, if I generate a mock out of it, it gave me this number, right? PAN number is this, and that is the unique key that I'm using over here, right? Let's try to hit that. Let's try to hit this particular response, and right, this 4,000 and sorry, that's the PAN number, that's the unique key that I have, and then I hit it, right? So as you can see over here, okay, user it is not picking up because I might have changed it to body. It should be params, right? I'll just do a restart. Let's create a user. That's the same user I get, and yep, let's try to hit it again. Oh man.
You need to change the user, I guess.
Oh, I did not select. It was selected as 0. So this is 1. I go and update this and get it. Yeah. So as you can see, now it fetched me the correct response. It was 5 lakh. So it is as simple as doing that. So once you add a type of response, now you have immense possibilities, right?
When you say generate a response on the UI, right? It creates a unique record.
Yeah.
Yes.
So
Effectively, yes.
if you'll have a look, it kind of sends me, it calls this particular API with my payload, and it ends up creating a very specific unique key value. So the way we store it is, I'm not sure whether it's visible or not.
So in a nutshell, it is effectively generating the test data that you need to use for that particular scenario. The combination of responses that you've selected, it will, in your journey, it will kind of give you those responses, and that's.
And as part of our automation test suite, this is the same API that we'll use to kind of create multiple different responses. Any questions?
Okay. So just for the sake of live audience, the question was that do we clean up the data or can we reuse the data? So what do you know?
Yeah. So I think it depends. Generally, the way I've used it, because it's so easy to kind of create a new data and test it out. Generally, people tend to kind of keep on creating new data. It is stale data, but it is in a different database altogether. It is not impacting your systems at any point of time. Whenever you feel that database is going slow or you want to do some cleanup, you are free to do that, because it's a completely separate database or data store that we spin up with the mock server. So you are free to do that. But ideally, the best case scenario is, because again, when we talk about test data, the state of the test data can be changed, right? And if you're reusing the same test data, that kind of causes that problem of what do I do with the change state? I would have to reset that, right? So we are kind of in a way avoiding that overhead of resetting the state of the test data just by creating a new one, because it's as simple as just clicking a button, right?
This is open source or
We are, it is currently open source. We are just working on it. It's not completely ready. I think it's in beta or something. Kind
Not
of
even
like
beta,
beta.
before that.
Before
We
that, yeah.
have opened the repositories, but it's a very initial days of working. So we want to aim at to make it a good open source to be consumable for user, and that was something coming soon, I'll say.
there is something called contract driven development, right?
CDCs, yes.
Yeah. So you have third party APIs, they publish their contracts, right? And you test against
Yeah.
those, right? So this could be replacement in case the client don't have these contract APIs.
But there, okay, so if I go into specific of, let's say, Pact, for example, you'll have Pact broker, and you'll have some servers giving the contracts to generate, and that is very effectively related to the OpenAPI specs or contracts. There is no, rather there is no concept of data there. We just ensure that whatever the data is in the correct format of the response, right? This is more essentially into the responses that you get from it, the actual data that is in the responses.
So I'm trying to understand do still I need a pact contract development along with this or no? So
That
this is going to solve both the
Yeah.
problems.
If I would say it doesn't, it depends on case to case, but I would generally say that pack it's a completely different. CDCs is a completely different section altogether.
Yeah.
So if we,
Because here we are also
So-
testing the API contract in a
Correct.
shell, in like
I
kind of,
ha-
because
Well, I can take that. So, contract testing may be a replacement for your integration tests, right? Where you do, rather than your producers testing your applications or calls, you are doing it via the consumer's point of view, right? What contracts the consumers has. Uh, Whereas when we talk about this is much more from the point of view of solving your end-to-end testing needs. I would say that. Again, uh, with contract testing, you are identifying whether the contract between two parties is correct or not at a much more initial stage, rather than even before deploying it to a dev server, say, for example, right? You run your test as part of your unit test. So that is where contract testing kind of shines, because you are running it as part of your unit test. You already have the contracts that were created by your consumers. You so suppose you are a service which is being consumed by many other consumers. Your consumers create these contracts which they are consuming, and there's a backed broker, and you use that backed broker to run your tests against that, right? So this is something that is happening at a unit level. What we are talking about is one level above that. Once you have all your integrated system, that is where you want to kind of bring this in.
but I'd like to say that that's an interesting take. So probably we can think it of when
Yeah.
we open source it.
so because what I'm like thinking is you will use this modulus, right?
Mm-hmm.
Most probably to the external systems, right? Which is outside your
Exactly.
fabric or whatever organization, right? Because that's where you don't know the for your internal service you will have your own dev systems or staging
Correct.
systems, right? So you can test your dev environment against the real dev service, right?
So, uh, if,
So let's say
that
your
is true, yeah.
service A, right?
Mhm.
You not need to test against B, which is in-house, right? I need a mob, right? You can test against B,
So-
which is real dev. In case of third party, right?
Yeah,
There you
but-
don't have the control.
Correct. So, generally, again, right, one very fine distinction that I would like to make is you're building an application, you may have multiple different microservices. Now, these microservices, I expect it to be part of my system, right? You may be connected to different systems within your organization itself, right? In an enterprise, say, you have an enterprise business bus and you're connected to that particular ESB, right? And these systems are out of my control. It is managed by a completely different team. Their uptimes are managed by them, and everything is being managed by them. And that is where it creates a problem even within an organization, right? Because I would have to align my roadmap, their roadmap with my roadmap, saying that, okay, I want to do contract testing. Are you willing to kind of take it up, right? And that is where the challenges occur. So,
I think
yeah.
you have fair point, but I also see a trade-off. It also delays
Okay, so I'll put this at the layer of anti-corruption layer. So whenever we are dealing with third parties, we'll probably have something in between to make sure that contracts are not getting broken off, or we manage them at probably something like APG, which is a gateway or some layer like that, right? So this system works at that layer where you are actually kind of mocking out the downstream API calls. Internally, everything, when you sit in the cluster, it looks like everything is happening, including the third party API calls. But effectively downstream, they are mocked, right?
Can I just share my 2 cents, at least my understanding of contract test versus what we're trying to do here, which is mocking. So contract effectively would validate whether the systems that are trying to consume data from others to the contract or not. So for example, and correct me if I'm wrong here, right? Like Experian as a system that I'm consuming, then whether Experian as a system is adhering to the contract that has been shared with me as a consumer will be tested via contract tests. So that is more before we even do an integration to ensure that the contract kind of abides with what Experian is sharing with you, where you need to hit the real data and compare it against the contract that has been shared with you, right?
Yeah.
So that's like one. The second, what we're trying to do here is mocking, which comes after, like I know that the contract, it adheres to the contract, I can safely mock it, which is something that I can do independent of calling the system. So I'm not even calling the system in
Exactly.
this case. I'm just mocking because
Yeah.
I trust Experian as a system.
Yeah, and
that's where mocking comes into
yeah,
picture. So
that is a fair point, and I think one of the points that Anuj is trying to make is you're somehow delaying that actual testing with with these external systems, and that is true to a fact, right? Because even if you're doing integration test, you are mocking it. Even if you're doing contract testing, you are testing it against the contract testing. But again, in my opinion, is most of these external APIs are just connected via HTTPS, and you might have to sort out some connections and other things, which you would anyways be doing it as part of your staging environment or QA environment. Uh, I am still okay waiting till it goes to a QA environment to test out these connections properly. Uh, but what is more important to me is to know and test out multiple different scenarios and make sure I am adhering to the quality and different scenarios within my application in an end-to-end setting. So again, as you mentioned, it may be a trade-off, like how do you want to kind of take it up. But in a completely CI/CD kind of a environment, usually what we used to do is you run your integration test as part of a CI, you deploy it on dev environment, you have mock server up over there, you run your smoke tests, you can also run your regression test suite, you take it to QA, and in your QA you are connected to the actual downstream systems. Or in certain situations, you even test out within your QA systems because of test data availability and all those things, and you just connect to the actual downstream systems in your UAT environment. So
just an addition to this, so while not currently there, but in the pipeline we have something like proxy setup. So effectively we have what we have done in past is have like a one set of proxy response where your mock server actually calls the downstream systems, because a lot of times that doesn't fail. So when I'm trying to, let's say QA is trying to test some new integration that is coming up, I want all of the other things to be in control in the mock while the new integration to still go through and have that test. So that kind of setup we have done it in some other setups, not part of Modulus as of today, but in the pipeline. Right?
cool. Any more questions? Yeah, I think that's pretty much what we had for demo. I'll just quickly go through the slides. This is again how the entire setup was done for the demo that we just saw with the banking application or the credit recommendation application and Modulus, right? It was an API virtualization sort of thing. Perfect. So just before we end, you can get connected with our talent acquisition team at Fabric. If you want, you can just take a. These are their LinkedIn profiles for Eva and Angela, and you can just shoot them a hi and take any additional information that you need from there.
You got from this viewer purpose?
So,
No.
you want to take that? Yeah.
From co-working, we have a co-working pass from MyHQ. So effectively, we have folks from all over India as well. So everyone can join into their nearest co-working space with their ease. So MyHQ is kind of an aggregator for all the co-working spaces. MyHQ. So it kind of, it's like your OTA or your make my trip
Aggregator, yeah.
essentially for your co-working spaces where so personally I can book something near to my place, he can book something near to us, and for all hands for once in a week we do come to a common co-working space as well.
And that's our career site. You can again, just go check those out. Yeah. Again, please do check out the openings at the career site. There would be more openings coming up in January 2026. And yes, thank you. That's it from our side. Please do share your feedbacks. It's really valuable for us. And
I hope this session was useful. By the way, we have some snacks around there. We have been instructed not to eat here, so we'll have to take them outside. But yeah, please don't leave without having those.
Can you explain briefly?
yeah, we can stop.
Thank you folks for having this.
Thank you.
Signing off from live stream as well.
Bye bye.
This is mainly an Australian company as well.
Yeah.
It's a product.
We are a service based company.